everybody, I'm talking about 4.NF.1 right now, which is an introduction to fractions and also understanding equivalent fractions. So we're going to get started with a basic introduction in our math notebook, and that is that a fraction, first of all, is part of a whole. So it is a whole, and sometimes we refer to it as pizza or a whole candy bar, and they are cut into parts. The parts are the fractions. The top number is a numerator, and that represents how many parts of that whole you are talking about. The bottom number is a denominator, and that is how many pieces are in the fraction, like how many slices in the pizza or how many pieces of the candy bar. That's just a quick introduction. Now what we're doing is talking about when we're thinking about a fraction, we're asking ourselves if it's less than, equal to, or more than a whole. But how do you know if a fraction is equal to a whole? A fraction is equal to a whole if the numerator and the denominator are the same thing. So for example, if you have 1 over 1 like that, that means you have one piece and you're talking about all of it. If you have 2 over 2 or 2 halves, that's basically talking about a pizza that's cut into 2. I know that because the denominator tells me, and I'm talking about 2 of the slices. So there's 1 and there's 2, which means I'm talking about the whole pizza. If I have 3/3, again, here's my pizza, cut into 3 slices. I know to cut it into 3 slices because the denominator tells me that. I'm talking about 3 of those pieces. So 1, 2, 3, and you can see that gives me one whole. So anytime the top number and the bottom number are the same, we're talking about a whole. It is equal to a whole. How do you know if a fraction is equal to 1/2? Well, the top number will be half of the bottom number. So for example, 1 is half of 2, 2 is half of 4, and 3 is half of 6. So I know that these fractions, these two, are the same amount of candy or same amount of pizza as this. If you look at these models, you can see here's a picture of a pizza cut into half or circle, and I'm talking about one of those slices to match this fraction. Over here I have a model that shows a pizza cut into 4 slices, and I'm talking about 2 of those. So when you color in the 2, you see it's the same amount as 1/2. The last one is a pizza cut into 6 pieces, and 3 of them are shaded, and you can see it is equal to a half. So what I want you to do on a sheet of scrap paper is go ahead and try to make a list right now of at least 3 fractions that are equal to 1 whole, and let's also do 3 fractions that are equal to 1/2. Give it a try. Okay, you could pause the video if you need some more time. Making a list of 3 fractions that are equal to 1 whole, you could have put any number as the numerator and the denominator as long as they matched. So for example, you could have put 4/4, 5/5, 6/6, 7/7. You could have even put 100 1/100ths. Any fraction, as long as the numerator and the denominator are the same, they are equal to 1 whole. Okay, how'd you do? Awesome. Now you're going to try to do at least the 3 fractions that are equal to a 1/2. And you remember that in order to be equal to a half, the numerator number has to be half of whatever the denominator is. So you can pause the video if you would like and try to write down at least 3 fractions equal to a half. So for example, you could have done 4/8, 5/10, 6/12, 7/14. You could have kept on going. You could have even done things like 50 1/100ths. As long as the top number is half of the bottom number, your fraction is equivalent or equal to 1/2. Okay, now we're moving along and we're talking about making equivalent fractions with models. So once again, an equivalent fraction is a fraction with different numerators and denominators that represents the same amount of the part of the whole. Okay, so for example, I can have 1 whole candy bar and it is the same amount of candy as having 2 halves. Over here, I have a candy bar that's cut into thirds. And all I have to do to show an equivalent fraction is if I divide that candy bar in half again. Now, instead of having 3 pieces, I have 1, 2, 3, 4, 5, 6. That becomes my denominator. And 1, 2 of those 6 are colored in. So I can see that 1/3 is the same amount as 2/6. Over here, I have a model that shows 1/4. And in order to do an equivalent fraction, I'm simply going to cut it in half. And I'm going to now have a fraction with the denominator of 1, 2, 3, 4, 5, 6, 7, 8. So I know that's 8s. And I have 1, 2 of those 8s covered up. So I know that 1/4 is equal to or equivalent to 2 8s. Now my models are going to get a little bit more advanced. So the top model here is showing a candy bar cut into 4 pieces, so fourths. I'm going to be talking about 3 of those fourths. So I'm going to first color those in. 1, 2, and 3. In order to use a model to show me an equivalent fraction for 3/4, I'm going to draw these lines down more so that now that I can see that my bottom candy bar has fourths, but I'm going to look for an equivalent fraction. So in order to do that, I'm going to cut each one of these parts in half also. So now instead of fourths, I actually have 4 times 2, or I have 8s. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 as my denominator. And to show an equivalent fraction for the 3/4, I want to color up to the equal line here. So we have the same amount. 1, 2, 3, 4, 5, 6. So I can see that 6 8s is equivalent to 3/4. They are the same amount of candy. Now, you can also use multiplication to create and rename fractions. What you do to the top, you must do to the bottom, and what you do to the bottom, you must do to the top. That is a very important phrase that we use in our class. Looks like I forgot to draw my line around. All right, so down here you can see that I know that 1/2 is equal to 2/4, and I ask myself, how did I get 1 to go to the 2? All I do is I multiply by 2. So if I multiply 2 by the top to get 2, I also need to multiply 2 by the bottom, the denominator, to get 2. Remember, whatever I do to the top, I must do to the bottom. I'm going to move over to this one. So first I say, in order to figure out what is missing, what did they do to the 5 to get to tenths? Well, they multiplied it by 2. If I do that to the bottom, I have to do that to the top. So now I have 3 times 2 gets me to 6. So I know that 3/5 is equal or equivalent to 6/10. One more time. If I have 2 and they gave me 4 as a numerator, how did they get to 4? I know again that they multiplied by 2. Whatever I do to the top, I must do to the bottom. So that means 3 times 2 is going to get me to 6. So 2/3 is equivalent to or equal to 4/6. On a sheet of paper, try to draw a model to show that 1/2 is equivalent to 2/4. And 3/6 is equivalent to 6/12. Give it a try. You can pause the video here if you need a moment to draw. We're going to start off by just drawing the candy bars. I'm going to draw a pretty generous rectangle. The top part is going to show 1/2. Okay, so there's 1/2. But I also need to show fourths. I know that if I take 1/2 and extend this down to the second candy bar, and then cut that bottom candy bar into fourths, it will now be able to show 1/2 is equivalent to 2/4. There we go. So here's the beginning of the next candy bar. I'm going to draw that pretty big. And I need to show 3/6 is equivalent to 6/12. So I'm going to draw my top candy bar. I know we're talking about halves, right? Because the top number, the numerator, is half the bottom, the denominator. So again, the numerator is half of the denominator. So I know we're talking about halves, so I can go ahead and draw that. On this side, I need to have 3. I need to have 3/6 to show 3/6. Down here, I have to have 6. So all I have to do is extend that down. So now I have 3 and cut those in half, just like that. Now we're making 12s. So now I need to show 1, 2, 3, 3, 6 is equal to 1, 2, 3, 4, 5, 6 twelfths. I hope you did that right. You can always practice with some other equivalent fractions on your own. Down below, you're going to do some practice with multiplication. So I did the first one. 1/3 is equivalent to 2/6, and I know that because I multiply the top and the bottom by the same thing. So whatever I do to the top, I must do to the bottom. So 1 times 2 got me to 2, and 3 times 2 got me to 6. So go ahead and give it a try. You can stop the video and do these on paper. Pause it, and I'm going to go ahead. So I know in order to get the 5 to 10, I had to multiply by 2. So if I did that to the bottom number, I must do that to the top number. So 2 times 2 is going to get me to 4. So I know that 2/5 is equivalent to 4/10. On to this one. In order to get the 7 to 14, I'm going to also multiply by 2. So I know 5 times 2 is going to get me to 10. So 5/7 is equivalent to 10/14. If I come down here, I know in order to get the 2 up to a 4, we multiply by 2. So I have to do that to the bottom number. 9 times 2 is going to get me to 18. So I know 2/9 is equivalent to 4/18. Over to this one. In order to get the 6 up to an 18, I'm going to multiply by 3. So then I must do that to the top as well. Whatever I do to the top, I must do to the bottom. Whatever I do to the bottom, I must do to the top. And that's going to mean that 3/6 is equivalent to 9/18. Last one. How did I get the 5 up to 10? Multiply by 2. So I'm going to multiply that 6 by 2, and I'm going to get it to 12. So I know that 5/6 is equivalent to 10/12. I hope you did great on that. If you need some more practice with this and you have your Eureka Succeed book, you could be working on lessons 7 through 11. If you look in the table of contents on the Eureka Succeed book, you will see fractions, equivalents using multiplication and division, and you can practice some more in your Succeed book. The next part of the standard is to show you that you can also rename or create equivalent fractions by using division. Just like we multiplied the same number by the top and also by the bottom, you can also do that in reverse, which is just division. So for example, if they give you 4/14 and you need to figure out if 2/7 is equivalent, you think to yourself, how do I get the 4 down to 2? I simply divide. So 4 divided by 2 got me to 2. So then whatever I did to the top, I must also do to the bottom. 14 divided by 2 gets me down to 7. So I know that 4/14 is equivalent to 2/7. Over to here, I think about what do I have to do to the 8 with division to get me down to a 2? I know I'm going to divide by 4. So then if I did that to the top and got 2, I also need to check to make sure I can do it to the bottom to make sure they are equivalent. Yes, they are. Over here, I got 6 needs to get down to 3, and I know I can divide by 2. Whatever I do to the top, I must do to the bottom, and there's an equivalent fraction again. Last one, can you figure that one out? It would be 3. 6 divided by 3 got me down to 2, and 15 divided by 3 gets me down to 5. Okay, you're going to give that a shot too. So here's some for you to practice on a sheet of paper. You can pause the video right here and practice doing a few of these, see if we can match our answers. Okay, so I know that 12 divided by 2 will get me down to 6. So that means I need to divide this 6 by 2 also and get me down to 3. So I know that 6/12 is equivalent to 3/6. Over to this one. I know that in order to get 12 down to 3, I had to divide by 4. And so I do that to the same, to the top number, to the numerator, and that will be 1. 4 fits into 4 one time. Come over here, getting the 18 down to a 6, I had to divide by 3. So I'm going to divide the numerator also by 3 and that's going to get me down to 2. So I know 6/18 is equivalent to 2/6. Over to this one. We left this one blank. So what could we do to get this number to an equivalent fraction? Well, I can look at these and I think to myself, I know 4 fits into both of them. So if I divide the top number by 4, I get 2. And if I divide the bottom number by 4, I get 3. Same thing down here. I have 12 and 18. I have to, really what we're doing here is simplifying the fraction, and simplified fractions or reducing fractions are actually also equivalent fractions. So what we have been doing, multiplying and dividing, is also giving you simplified fractions here. So if I get down, I'm thinking about what number could go into both. I'm thinking about 3. So if I go 12 divided by 3, I get down to 4. If I get 18 divided by 3, I get over to 6. If I was going to simplify this fraction, I could still keep on going. So if I divided both of these by 2 again, I would get down to 2/3. Okay? And once again, if you take your Succeed book and you go to the table of contents, you can see that there are lessons in here that you can practice these skills on. Lessons 7 through 11 would be helpful for you to practice. And that looks like page 31 to 51 if you have your Eureka book. If not, you can practice making some more on your own or start the video over. Hope this helps. Have a great day. Bye.